All right, this is a big skill. Here we go. A little reminder. When I'm factoring, the first thing I'm going to look for is, do I just have an x squared out in front? And look, for the first few examples, the answer is yes. How does that x squared happen? So remember, we're going to factor. It's going to look like this. This x squared comes from multiplying x times x. Look, so x times x is going to get me x squared. Now, what's going to happen, and look, I have all positives here, so I'm going to use this one as kind of a reminder. But if you remember, what I'm looking for is I'm looking for two numbers that multiply to this and add to this. Okay, so multiply to 28, add to 11. Now you can use your multiplication chart, but two numbers that multiply to 28, right? Like it could be 1 times 28, could be 2 times 14, could be 4 times 7, okay? But in this case, what I'm looking for is two numbers that multiply to 28 and that add to 11. So that's the number 4 and 7, okay? So this is the answer. And just a reminder about why it works. Remember, factoring is the opposite of multiplying. So here, if I were to multiply this, I would do x times x, that'd be x squared. Then x times 7, that'd be plus 7x. Then this plus 4x, and then this plus 28. And then remember what happens is I add these two to get 11x, right? So what ends up happening, right, is that x times x is x squared. These two numbers multiply to get this, and these two numbers, right, this becomes 7x plus 4x, and they end up adding to get this. Okay, so this is the answer, and that's kind of why it works. So here, again, I'm looking for two numbers. Look, I noticed that this is x squared, so that's going to be x times x. And I'm looking for two numbers that multiply to negative 40 and add to negative 6. Now, if I'm going to multiply to a negative, I need to have one positive and one negative. That's the only way two numbers are going to multiply to a negative. Now, when I go to add these two numbers, look, one's positive and one's negative. So what happens when I add a positive and a negative? I end up subtracting them. So what I need is two numbers that multiply to 40 and subtract to 6. So let me think, like, let's see, 5 times 8 is 40, but those don't subtract to 6. 4 times 10 is 40. Oh, look, those subtract to 6. So these two numbers are going to work. Now, what I want is one of them to be positive and one of them to be negative. Either way, they're going to multiply to negative 40. But when I add them, I want them to get to be negative 6. So what I need is to make my larger number negative. Okay, look. So here, 4 times negative 10 is negative 40, and 4 minus 10 is negative 6. Okay, now if I had the sign switched, it would be 10 minus 4. That would be positive 6. Okay, but this is my answer here. On this one, I need two numbers that multiply to positive 42 and add to negative 13. How can two numbers multiply to be a positive and add to be a negative? The only way is a negative times a negative. A negative times a negative is a positive, and negatives plus more negatives is a negative. So what are two numbers that multiply to 42 and add to 13? Those two numbers are 6 and 7, and it doesn't matter the order. Here's my answer. Okay, one more similar to this. This one, notice there's only two terms. This is x squared plus, look, that b value is 0, right? We talked about that up above. That's this. So what are two numbers that multiply to negative 25 and add to 0? Okay, well, if I need two numbers that multiply to a negative, it's going to be one positive and one negative. And two numbers that multiply to 25, and then when I subtract them, because one positive, one's negative, I get 0, well, that would be 5 and 5. Right? So this is going to be x plus 5, x minus 5. And the order doesn't matter. This could be the negative, this could be the positive. It doesn't matter. Okay, here. Look, now I don't have just x squared out in front. When I see a problem like this, I need to ask myself, is there a GCF? In this case, the answer is yes. There is a number that multiplies to 5, 20, and 15. And that number is 5. 5 times what is 5x squared? 5 times x squared is 5x squared. 5 times what is 20x? 5 times what is 20? 4. And 5 times 4x is 20x. 5 times what is 15? 5 times 3 is 15. Okay, now look, I have another step to do. I'm going to bring down my GCF, and now, look, I'm going to ignore it. Now I'm looking for two numbers that multiply to 3 and add to 4. Look, this x squared comes from x times x, and there's only two numbers that multiply to 3, 3 and 1. Everything is positive here. Okay, and this is my answer. Here's another one where I don't have x squared out in front. I'm gonna ask myself, is there a GCF? Is there a number that multiplies to 3, 11, and 10? And the answer is no, there's not. Okay, 3 is a prime number, so is 11, so I'm just gonna have to go like this. Okay, and a reminder, this times this equals this. Okay, this times this equals this. And then in order to get this middle number 11x, it's gonna be this times this plus this times this. Okay, so let's do it. This times this equals 3x squared. So the only numbers that multiply to 3 are 3 and 1, so this is going to be 3x times 1x gets me 3x squared. Now some numbers that multiply to 10, that could be 10 times 1, and it could be 5 times 2. Okay, so we're just going to try a set of numbers. I notice everything here is positive, so I'm going to go ahead and put my positives in here. And let's just try. Let's try, I'm going to put a 2 here. Look, and I'm writing really light because I might have to erase, and a 5 here. Look, 3x plus 5, that's 15x plus 2x. That equals 17x. So that's a no. I want it to equal 11. Let's try switching them. Now, if when I switch them, if it doesn't work, then I'm going to cross off 2 and 5 and try 10 and 1. Let's try this though. 3x times 2, that's 6x. 5 times x, that's 5x. Oh, hey, that does equal 11x. Okay, so then I can just darken this up a little bit, and I'm all set.